Alright folks, so today's video is on the atomic anatomy notes. This will be our next to last note session for this unit. Today we want to look at how to determine for each element how many protons, neutrons, and electrons are in the atom and where they are. The where they are piece is going to be rough nucleus or electron cloud. Future chapters we're going to build out the idea of the electron cloud having layers a little bit more in detail. But what we want to do today is focus on the understanding of how to use the information on the periodic table to determine the number of protons, neutrons, and electrons in an atom. So first things first, we know the atom is the smallest form of any element. Smallest form of any element that retains the properties of that element. Okay? Anatomy, by definition, is the study of the parts that make up the whole body. So if we put those two things together, we're really focusing on understanding what parts make up the atoms. So why do we need to understand the structure of the atom? Well, each element's atom has unique properties. These properties are dependent on the makeup of the atom. In particular, how many protons are in the nucleus and the electrons, specifically the electrons on the outermost energy level. So, we know the parts of the atom from our previous discussion. We talked about Thomson discovering the electrons, Rutherford discovering the protons, and Chadwick discovering the neutrons. So if we want to define what the parts are, the parts of the atom, protons are positively charged particles that are found in the nucleus. Neutrons are particles that are found in the nucleus that have no charge. The proton and the neutron are roughly the same mass. They're almost identical in mass. The electron is a very, 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 very small particle, and it is found orbiting the nucleus in shells, and it has a negative charge. So it's a particle with a negative charge that is found in the region surrounding the nucleus. We call that the electron cloud. Now, if we look at our diagram of the atom here, we have the nucleus, which contains over 99% of the atom's mass and takes up less than 5% of the atom's volume. It's the center or the core of the atom where the protons and neutrons are found. It has an overall positive charge because it has positive protons and neutral neutrons. So all the positive nature of the atom is found in the nucleus. The electron cloud is opposite of the nucleus. It only accounts for about 1% of the mass, probably less than that, to be honest. And it takes up over 95% of the volume. Talked about this a little bit yesterday in the last video, that if you had a golf ball and you put it on the 50-yard line, and then you took a metal BB, like this guy, and you put that on the back of the end zone, and then made that distance the radius of the cloud, and then spun that in 3 dimensions, that one electron orbiting that single proton would be the hydrogen atom. That's a lot of empty space if you think about a 60-yard radius sphere that contains a golf ball and a proton and an electron. The atoms are mostly empty space. Okay? Remember that the nucleus is where all of our positive particles are found. The electron cloud is where all of our negative particles are found. Now, when we go to the periodic table, we're going to find two principal numbers that are useful to us on the table. The atomic number, that is represented by the letter Z, and the mass number, the average atomic mass, which is represented by the letter A. We can find those by using the key or the legend to our table. And you can see here that on this table that we're using as a class, you have your element symbol, the element name. In between those, you can find the atomic number. Underneath the symbol, you'll find a digit, typically to 2 decimal places. That's your average mass. Now, what does the atomic number tell us? This came from Moseley. The atomic number tells us the number of protons in the nucleus of an element atom. The atomic number tells us the number of protons in the nucleus of an element atom. Hydrogen has an atomic number of 1. It has 1 proton in its nucleus. Oxygen has an atomic number of 8. It has 8 protons in its nucleus. Matter of fact, how we can determine or identify one element compared to another is by looking at the number of protons. So, in essence, our atomic number is essentially like our Social Security number. It's our ID. It's a number that identifies what the atom is, what kind of atom, which element it is. Okay? Now, we're going to learn right now, for the time being, that all of our elements are neutral, meaning the positive and the negative charges cancel each other out. So until we go over ionization later on, you can assume that the number of electrons is equal to the number of the protons. The number of protons is the atomic number. The atomic number is the number of protons, period. If the atom is neutral, then the number of electrons and protons will be the same. The number of electrons is not the atomic number. The atomic number is the number of protons. Okay? Now, the mass number tells us how many particles are in the nucleus. So what you're going to do is you're going to round these values. You're always going to round the average atomic mass to the closest whole number. The majority of them have decimal places in their values. For instance, if we look at mercury, it says it's 200.59. So that is the average mass. The mass number would be 201, because the 5 would round the 0 to a 1. Okay? Nitrogen, right here. Nitrogen has an average atomic mass of 14.01. Its mass number is 14. Boron has an average atomic mass of 10.81 units. Its mass number would be 11. You always round to the closest whole number. So the proton is found by the average atomic mass. The electrons and protons are the same for the time being. And the mass number is the protons plus neutrons together, the total particles in the nucleus. Protons plus neutrons, that's what the mass number is. So how do we find protons, neutrons, and electrons in an atom? Well, let's use carbon as an example. Carbon has an atomic number of 6 and an average atomic mass of 12.001. This top number is the atomic number. That's how many protons we have. So how do we determine the protons? It's equal to the atomic number. How do we determine the electrons then? Electrons are equal to protons if it's neutral. That's a big if. For right now, we're going to assume that that's true. So we have 6 protons then, and you have 6 electrons. Then how do we determine the neutrons? Well, if the protons in the nucleus are the atomic number, and the mass number is protons and neutrons together, we have to take the mass number minus the atomic number. So take your mass number minus your atomic number, and that's going to give you the number of neutrons. So for carbon, the mass number is 12 minus the atomic number of 6. We're going to end up with 6 neutrons. Okay? Let's look at one more example here together. Let's use chlorine. Okay? Chlorine has an atomic number of 17 and a average mass of 35.45. So if we come down here and we say, okay, well, chlorine is atomic number 17, mass is 35.45. This is my atomic number. So the number of protons is equal to 17. If it's neutral, and we're going to assume that it is for right now, the number of electrons is also 17. And then the mass number, if we take 35.45 and we round that to 35, that would be my mass number. Okay, that's my mass number. Take your mass number minus your atomic number to get the number of neutrons, and that's going to give you 18. Alright? Let's take a minute, review these, and then you can go ahead and answer the practice problem set for the particle prediction. That is in the same place where you found this video.